Hey guys, and welcome to our estimation challenge. I hope you joined us for our previous lesson on estimation by rounding, because today we're doing a bit of a challenge where I'm going to try and get you to think outside the box, because there's not always just one correct answer, particularly when we're estimating. Let's get started so I can show you what I mean. Suppose we wanted to calculate 143 times 483. We could do this exactly using long multiplication, or we could approximate an answer to this by rounding and working with easier numbers. For example, we could say that 143 is approximately the same as 100. As rounding to the hundreds position, this becomes 100. In the same way, we could say that 483 is approximately 500, because a 4 in the hundreds position with an 8 next to it would round up. 100 times 500 is a much easier calculation for us to do. If you know that 1 times 5 is obviously 5, you should know that 100 times 5 is 500, which means that 100 times 500 must be 50,000. Notice I just put on an extra 2 zeros, shifting all of my place values up 2 places. Now this estimate's okay, we did round correctly, but we will have quite a big rounding error, as 100 is 43 less than 143, and 500 is 17 more than 483. A more accurate estimate might have been 100 times 483. And multiplying by 100 is fairly straightforward, regardless of what you're multiplying it by. If you know that 1 times 483 is 483, 100 times 483, I just tacked on 2 zeros. That's 48,300. And again, we could do another estimate, where maybe we keep the 143 perfectly accurate, but we multiply it by 500. Now this one's not as straightforward. However, there's a good trick for multiplying by 550s, 500s, and so on. 500 is just half of 1,000. So 143 times 500 is the same thing as 143 times 1,000 and then divided by 2. To do 143 times 1,000, I just need to shift my place values up 3 places. So I'll tack 3 zeros on at the end there. Now the 1 that was in the hundreds position is in the hundred thousands position. And the 4 that was in the tens position is now in the 10,000 position. And the units is now the thousands position. Now I just need to divide by 2. We can go digit by digit, and we always start at the leftmost digit. Now I can't do 1 divided by 2, but I can do 14 divided by 2. 14 divided by 2 is 7. So I've got 7, and then I move on to the next place value. 3 divided by 2 is 1, but there's 1 remainder. 1, and then bring down a 0, that would be 10. 10 divided by 2 is 5. So I'm going to have 7, 1, 5, and don't forget the zeros. We need to keep the correct place value, 71,500. So 143 times 483 could be estimated as 50,000 or 48,300 or 71,500. Now all of these estimates are quite different. Which one do you think is the most accurate? Of these rounded values, which ones are closest to the original values? I'm going to go with the third one. 143 is exactly accurate, whereas when we round it to 100, it's 43 less than it should be. 500 has been rounded up from 483, but it's only been rounded up by about 17. So I'm going to guess that this is the most accurate estimate. You can go ahead and calculate the original calculation for yourself to see. In this next question, I've got 4 different students and they've all estimated the answer in different ways. This first student thinks the answer is 400. The second student thinks it's about 358. The third thinks it's 358.2, and the fourth thinks it's about 300. How do they all get such different answers? Think of all the different ways they could have rounded the original values. They could have rounded 3,582 to the nearest thousand, and that's a nice easy number to work with. Or they could have rounded it to the nearest hundred. That would be 3,600. Again, not too difficult to work with. Or they could have kept it correct to the nearest 10, 3,580. Or they could have kept the value exact, so correct to the nearest unit, 3,582. The 11.7 as well could have been rounded in several different ways. They could have rounded it to the nearest 10, making this 10, because 1 with a 1 next to it will not round up. They could have rounded it to the nearest unit, which would make it 12, because 11 with a 7 to the right, it's bigger than 5, so that rounds up to 12. Or they could have kept it exact, 11.7. So thinking of all of these possible values that they could have divided, which values do you think the first student used? 4,000 divided by 10. Remember that to divide by 10, all we need to do is move all of the place values down one place. That is, if you've got a whole number value that ends with a 0, we can just take that 0 off. 4,000 divided by 10 is 400. So maybe the second student did something similar. 3,580 divided by 10. Again, dividing by 10, we just need to shift all our place values down one. And 3,580 ends with a 0, so I can take that 0 off, shifting the 8, which is in the tens position, down to the units. The 5 that's in the hundreds position shifts down to the tens, and the 3 that's in the thousands position shifts down to the hundreds. So 3,580 divided by 10 is 358. The third student got a decimal answer. How did he work out a decimal answer without a calculator? Again, remember, dividing by tens is as simple as shifting all of the place values down. With 3,582, dividing by 10 might seem more difficult because this number does not end with a 0. But shifting all place values down might also involve simply moving a decimal. This is a whole number here, but if I divide it by 10, the decimal, which is hiding at the end of the number, shifts over one place to in front of this 2. Moving this 2 from the units position into the tenths position after that decimal. And the 8 that was in the tens position is now in the units position directly to the left of my decimal. So 3,582 divided by 10 becomes 358.2. What about our fourth student here? She seems to have a very different answer from the rest, and I don't know how she got it. Surely she didn't do 4,000 divided by 10. That's what this first one did. But how did she get such a nice round number, which is simply 300? Hopefully you noticed that 36 can divide perfectly by 12. If you can do 36 divided by 12, which is 3, you can do 3,600 divided by 12. If I put 2 extra zeros on there, I'll put 2 extra zeros on my answer. 3,600 is simply 36 times 100. So while 36 divided by 12 is 3, 3,600 divided by 12 is 300. We have now successfully worked out how each of these students got their estimates. I'll leave you with a challenge question for yourself. See how many possible estimates you can make for this calculation. I look forward to seeing your estimates down in the comment section. Till next time, keep practicing, and I'll see you soon.